In this lesson, we will learn about the merge-sort algorithm. Begin by downloading the merge-sort algorithm document in either Microsoft Word format or PDF so that you can follow along during the lesson. The merge-sort algorithm is very complex, and it will be very helpful if you can refer to this document as the lesson continues. Finally, you will also want to download the MergeSort Introduction project to import into Eclipse. Let's begin by bringing the project into Eclipse using File, Import, Existing Projects into Workspace, browse to where you have the file stored, and then click Finish to import the project. The project has some skeleton code in it that will help us develop our program a little bit more quickly. But we will not start with this method. We will begin by creating a new class within the default package. This class will be called Combine List or Lists, and it will have a public static void main method. Click Finish to begin, and as always, we'll delete the extraneous comments, use the one remaining comment in the main method to put your name into your code. Before we begin, let's look at the Word document to get an idea of what we will be attempting to accomplish. The merge-sort algorithm is actually made up of two parts. In one part, the merge-sort algorithm takes two lists and merges them together. The important part about this algorithm is that each of the lists is already sorted into ascending order. If it's a numerical list, that means, of course, that each of the lists is numbered with the lowest number first, going up to the largest. Those two lists get put together into a combined list, which then has all of the values in numerical order. In the example diagram on the first page of the merge-sort algorithm document, you can see that one list has 2, 3, and 5, the other list 1, 4, and 6. Those two lists will be combined to give us a list of the numbers with 1 through 6. The code will be right here that we'll be putting in. So, we'll begin by creating our two lists. Two integer arrays, we'll call them list 1, and we'll just give them our initial values. We'll also create a list 2, which will have our other set of values. The only requirement at this point for these two lists is that each list is in numerical order. And then finally, we're going to need an empty list that we can use to hold our combined list. And therefore, we use the new operator to create a new integer array, and the size of the array is equal to list 1's length plus list 2's length. Now, of course, we could have just said a length of 6, but writing the code this way makes it more flexible. If we wanted to test our program by changing the values in our lists, this code would continue to work. It is more robust when written this way. Okay, next we need to create a couple of index variables. So we're going to have list 1 index and set it to 0, and then also list 2 index, which will also be set to 0, and then finally a combined list index, which will be set to 0. In our next step, what we will be doing is writing the code that will go through these lists and merge the two lists together. So, what are these variables and what do they mean? Well, list 1 index is going to tell us which portion or which value within the list is the next one that needs to be processed. List 2 does the same thing for list 2. And then combined list tells us which element we're on within the combined list. Okay, let's begin writing our method. So, the first step is to write a loop that will continue as long as either of our lists has an element that has not, actually, as long as both lists have elements in them that have not yet been processed. What does that mean? Well, that means that if the index, for example, of list 1 is still less than list 1's length, then our loop should continue. But only if the list 2 index is also less than its list length. What this essentially means is that of our two lists, both of them still have elements in them remaining to be processed. When list 1 index reaches the value of 3, it means that all the elements in that list have been processed. Of course, there's no code to do that yet, but that's what we'll be writing very soon. So, now what we need to do is write our actual statement that figures out which list we want to take a value from. And what we want to do is take the value that is lower from the two lists. So, this is going to be an if statement. Well, what is our conditional? Our conditional is going to look at list 1, where we're pointing to in that list. Remember, list 1 index tells us which element we're processing from that list, and compares its value to list 2 list index. And if that value is less than the value in list 2, so for example, right now when we run this program the first time, each of these values, these two list indexes, have the value 0. So it's comparing 2 and 1. And what it would say is if 2 were less than 1, of course it's not, so let's write that also. That will be our else. We now have two possibilities. Either the value stored in list 1 is lower, or the value stored in list 2 is lower. Since in our example here, the value stored in list 2 is lower, let's write that else condition first. Well, what do we want to do? What we want to do is take the value from this list, list 2, because it has the lower value, and store it in the next position in combined list. So what is the next position in combined list? Of course, its next position is the value pointed to by combined list index. So its value gets the value of list 2 at position list 2 index, because that's the element that we're on in that list. Next, what we need to do is we've just taken an element from this list. So the next time we're examining that list, we want to go to the next element, which would be 4. To go to the next element, we increment that list index. And that's all there is to it for that one. Now, obviously, 2 was not less than 1, but sometimes the value stored here will be less, and we need to process it. It's essentially exactly the same. We take the combined list index, but this time we set it equal to the value of list 1 at its index. Okay, now we've either done this or we've done this. In either case, oops, we forgot one little thing. We need to increment list 1 index. That would not have worked. Okay, now back to our lesson. If we have added an element to combined list, then the next time that we process it, we need to go to the next element in its list. So we need to increment the combined list index. Now it's worth noting we could put this command in both the if and the else, but since one or the other of these happens, either way a value has been added to the list and we can increment it. So instead of putting it in there twice, we're simply going to include it once. Okay, now at this point let's follow the code and see what would happen. Well, when list 2 index and list 1 index both have 0, it will compare 1 and 2, copying the value 1 into the combined list. Then it will take the next item from list 1, which is still 2, and compare it to 4. In this case, 2 will be less than 4, so it will take 2, and the next item on that list will be 3, and the process will continue. So, all we need to do now is, it would be nice if we could see the results of our labor here. So, let's write a little method that will let us see the results of our array. By now, this should be fairly old hat. We're going to list the contents of our array, and we're going to write a loop that iterates over all values of the array, incrementing our value for each step, and then we'll just print out the value. We'll also print the index of the value that we're outputting to make it a little bit easier to read. Okay, so what we're going to want to do is print out our list after we have combined our lists. So we'll say list combined list. Okay, now we're going to put a stop into our program right here so that we can watch as our program runs through this process step by step. Keep in mind that as you're doing this, if you look at this diagram, you should be able to follow along and see what's happening. It should be filling in combined list one step at a time from each of our 2 sublists. Okay, so let's run it in debug mode. Alright, now, if we click on combined list down here, we can see its current list of values displayed down below. Since list 1 and list 2 are relatively short, we can also open them up so we can see their values. And since we're not going to see anything in the console for a bit, we can shrink that down. Okay, so we can see that at this stage of the program, list index 1 and list index 2 are both 0, as is combined list index. So let's run our program one step at a time. So as we can see, since the value stored at list index, or list 2 index, is lower than the value at list 1 index, it's going to take that value and copy it into combined list. So we get 1 added to combined list. What's going to happen on the next iteration? If I hit resume, it will go back up here. What value will get copied into combined list next? Well, of course, it should be 2, which is the next value of list 1. Because, as you can see, list 1 index here is pointing to element 0, which has the value 2. List index 2 is pointing to index 1, which has the value 4. 2 is less than 4, so if I take one step in my program, it goes here, combines, it's going to copy list index 1's value into the combined list, and now I can see that I have 1 and 2. Let's run it, and this time we're just going to step through by hitting resume, one step at a time. We can see that we got 3, 4. What's our next value? Well, our next value in the list should be 5, but is that what happened? Let's switch back to our Java view and run the program and see what results we get. 1, 2, 3, 4, 5, and 0. Why isn't the last element filled in? Well, this is a very important step in the merge process. Remember that our loop stops as soon as one list gets to the end, runs out of values to compare. So what we have to do now is copy the remaining values from the list that still has some values in it. So this is going to be another while loop. Now, since we don't necessarily know which list has the values in it, we need to do a while loop for each list. So we're going to say while list 1 index is less than list 1 dot length, and then we're simply going to copy any remaining values in that list. So we'll say combined list index equals list 1 index. And then we need to increment both list 1 index and combined list index so it can complete the copying process. Okay, now that takes care of list 1, but what about list 2? Well, it turns out this is fairly easy. All we have to do is copy and paste our code and change our list 1s into list 2s. Everything else remains the same. So, once again, why do we have 2 while loops? Well, let's remember that one of these 2 list index variables will have reached the end of the list, which means that that while loop will not execute. Which one will it be in this case? Well, we can run it in debug mode again and we can watch this happen. What we'll do is we'll put a stop here and we'll put a stop here so we can see when one of these 2 while loops gets reached. So, we're going to copy. We see that 1 gets put in the list, then 2, then 3, then 4, then 5, and now our top while loop up here has completed. Notice that it has skipped list 1's while loop completely because only list 2 has a value in it remaining to be copied. 6 still has to be copied into our combined list. So let's watch that happen. There we go. It should have just been copied. And our program is done. So now let's run it in Java, in our normal Java mode, so we can see, Java out of bounds exception on combined lists line 26. Oh, I missed a 2. I didn't change that list 1 to list 2. Okay, well, that takes care of that. And there we go. Now we see that our list has been combined in order. Now, the important thing to understand about this process is that this only works if each of the sublists has already been sorted. But remember, our whole goal here is to take a list that isn't sorted and sort it. So how does this help us? Well, the merge sort algorithm is often referred to as a divide and conquer algorithm. What it does is it divides the list that we're going to be sorting into smaller lists and then proceeds to merge the smaller lists one at a time. So we'll see how that works very shortly. Before we do that, we're going to take our program here and we're now going to make this process more useful to us because so far we've taken 2 lists that are totally separate and merged them. But it turns out that this isn't a very convenient way to work. So in the next portion of this lesson, which will continue shortly, in the next video, we will take the same process and we'll write it as a method that operates on one big list, but operates by taking 2 portions of that list and merging them.